What are your first thoughts that come to mind when you think of organic chemistry? Most people do not react too positively when they hear these two words because of the rigorous nature of this course. Though organic chemistry does not receive too much popularity, its applicability to real-world concepts can make it interesting to just about anyone. In fact, for me, as an aspiring dentist, I utilize the mechanisms and concepts that I learned in organic chemistry in order to help me have a better understanding of antibiotics. When you're prescribing a patient with antibiotics, you obviously need to know how they work in the body and how they get rid of the bacterial pathogens. So, utilizing the organic chemistry mechanisms and concepts that you learn in the course can really help you do just that. So for all you aspiring healthcare professionals, and for all of you that are looking to work with medication in the future, I'm here to tell you how organic chemistry plays an important role in the mechanisms of how antibiotics fight bacterial pathogens. As you may know, there are many types of antibiotics. The particular antibiotic that I'm going to talk to you about is sulfonamide. Sulfonamide was actually one of the first antibiotics to ever be synthesized and used among patients. Sulfonamide was found in a red dye called protonsyl and was metabolized by intestinal bacteria to yield sulfanilamide. And then sulfanilamide was then synthesized by chemists in a laboratory and was the first synthetic antibiotic to treat bacterial infections. Now that you know a little bit about sulfonamide, let's see how it works. In order to understand how it works in the human body, you must first understand how bacteria replicates. This graphic shows a step-by-step reaction on how that occurs. Understanding the arrow pushing mechanisms that we learn in organic chemistry can really help you make sense of the whole replication process. The first mechanism that occurs in the replication process is para-aminobenzoic acid reacting with the bacterial molecule when it enters the body. Dihydropteroate synthetase is an enzyme that is utilized to bond these two molecules together. As you can see, the nitrogen on the para-aminobenzoic acid donates its electrons to the carbon that's bonded to the OPP group. This bond formation causes the carbon OPP bond to break as the new bond forms and the OPP group leaves the molecule. Following the completion of this mechanism, dihydropteroate is formed. Dihydropteroate then reacts with the L-glutamic acid. As you can see in the graphic, L-glutamic acid donates its electrons to dihydropteroate and forms a covalent bond between the two molecules. This particular mechanism causes the formation of dihydrofolate. Once dihydrofolate is formed, it binds to an enzyme called dihydrofolate reductase and is reduced into tetrahydrofolate. This continual process causes the replication of bacteria. In order to stop it in the human body, a molecule needs to inhibit one of the processes in order to stop replication from occurring. This is where sulfonamide comes into play. As you can see in the graphic, sulfonamide has a very similar chemical structure when compared to para-aminobenzoic acid, the molecule that is essential for the first part of bacterial replication. Since sulfonamide consists of an amide group similar to para-aminobenzoic acid, the nitrogen can donate its pair of electrons to the bacterial molecule in the dihydropteroate synthetase enzyme. So this way, sulfonamide can act as an inhibitor and prevent the replication process from occurring. As you can see, sulfonamide drugs do not directly kill the bacterial cell. They are bacteriostatic agents. They inhibit bacterial growth and enable immune cells in our body to attack the bacterial pathogens. These antibiotics would not be suitable for patients with AIDS or patients who have undergone chemotherapy because it only works effectively in people with a strong immune system. As you can see, having an understanding of the mechanisms and concepts that we learn in organic chemistry can really help you understand how antibiotics, particularly sulfonamide drugs, work to fight bacterial pathogens in your body. I really hope you learned something from this video and found it interesting, and I really appreciate you giving me your time to watch it. Thank you.